Hello everyone, welcome to Ace Academy's YouTube channel. My name is Arjun Chabra. I'm a faculty at Ace Academy. So today, your SSC JEE 2024 revision series subject steel structures we'll be covering in today's lecture. And most of the students know that steel structures is a very important subject for SSC JEE examination, both prelims and the part 2 examination, that is the mains examination as well. As far as the approach for SSC JEE examination is concerned, you all should know and that as the exam is nearby, first half of your day should be dedicated towards solving as many questions as you can, and the second half of your day should be dedicated to revision part, right? Write down a couple of topics one day before and try to cover up as many subjects as you can, right? Moreover, solving previous year questions in these lectures is not enough. You need to solve as many questions as you can through previous year questions which were asked in various state AE examinations also. There are a couple of books which are available in the market. You can refer those books for a revision part, right? Revision aspect for various exams, right? There are books known as youth publications for AE exam. Most of my students know about this, and I tell the students who are preparing for AE exams, they should go for these books. They are available very easily on various marketplaces. You should practice questions from that books. Moreover, you can go for previous year gate questions, right? Previous year basic gate questions you can go, and basic questions of engineering services examination pre-questions, right? They will be very helpful for you. And if you solve previous year SSC JEE questions, you'll see that some of the questions have been repeated which have been asked in GATE or engineering services. They have been repeated in SSC JEE, right? After that, you need to give emphasis on test series, both subject-wise test series and full-length mock test. Both of them are very important, right? You cannot ignore test series because you need to have a practice of solving questions upfront in a very small time domain. Upfront means you need to have a practice of solving questions which are new, right? Not only questions which have been asked before, right? So that's why test series is very important. Analyzing yourself in a particular amount of time, right? Finding your weak spots, weak subjects, right? That is the main task. As far as the weightage of various subjects is concerned, you can see over here, and you can also click a screenshot of this. It will be helpful for you while you are preparing for this exam. Now, our subject is steel design, and you can see a good amount of weightage is asked in steel, right? It is only in GATE examination that questions from steel is not asked, but in any other examination, consider engineering services exam, consider even UPSC examination for civil services, civil engineering part, right? And various state AE examination, SSC JEE, RRB JEE. Good amount of weightage is asked from steel design, right? So you cannot ignore this particular subject. After that, syllabus is quite easy. They have very much concised the syllabus in one or two statements. That's it. In one or two statements, they have mentioned steel design, construction of steel columns, beams, roof trusses, plates, girders, but more elaborate syllabus and chapters you need to cover. They are in front of you right now. You can see good amount of questions have been asked from material specifications. Not good amount of questions, very less questions, sorry. Design philosophies, yes, again, basic questions are asked from WSM and limit state method. Very high number of questions are asked from connections, right? Riveted, bolted, and welded connections. So there are two types of connections in general: simple connections and eccentric connections. Simple connections are in which there is no eccentricity or movement which is being induced, right? And eccentric connections in which there is additional movement due to the load, right? Intentionally applied in the connection. So which part we need to cover? Eccentric connections we need to ignore, because not even one question has been asked in SSC ever in from eccentric connections. So we can ignore eccentric connections and we can just cover simple connections, right? After that, members part. Members part, it is tension members, compression members, and beams, plate girders, base plates, and industrial roof trusses. So maximum questions from members have been asked from these three domains: tension members, compression members, beams, right? And I guess 95%, 99% of the questions we'll be covering today in this lecture. Plate girders, again, very less questions have been asked, but I'll be covering some of the questions which students cannot ignore. So I'll cover those aspects as well. Industrial roof trusses. I mean, I guess rarely they have asked from base plates, so you can again ignore base plates. Industrial roof trusses, again, basic questions asked. They have asked mainly from purlins, right? So purlins are actually beams only, kind of beams only. So we'll be covering them in beams only, right? Other than that, very less questions from industrial roof trusses as well. So what are the reference books and book code of practices you need to cover? So see, S.K. Duggal and N. Subramaniam. These two are the best books which are available in India for competitive exams. S.K. Duggal for design of steel structures, I'll say ignore this book. Just focus on this book if you want to excel in any competitive exam. Because in this particular book, after each and every chapter, there are objective type questions, right? And those objective type questions are directly asked. I'm saying directly asked in various state level exams and including SSC. Sometimes in SSC also, they have directly copied from previous year question, backside of the chapter of S.K. Duggal book. So again, you need to focus on this book, right? Have a soft copy of this book in your phone or laptop or computer. And various codes of practices, you can see IS 800 2007, very important. IS 800 1984. This is the older version in which WSM and ultimate load method is considered. After that, IS 800 2007, it is limit state method. Limit state method is considered, right? After that, IS 875, this is for loads. This is for loads. In this particular case, there are total 5 parts. Part 1, this is for dead load. Part 2, this is for live loads. Part 3, this is for wind loading. Part 4, this is for snow loading. Part 5, this is for some special loads and accidental loads, right? Now, directly questions have been asked in SSC. Keep this in mind. Asking about which code of practice is used for either live loads, either wind loading, right? Either for snow loading, right? Like that, they are specially asking. So, part 1 is for dead load. Part 2, this is for live loads. Part 3, this is for wind loads. Part 4, this is for snow loading. Part 5, and this is for some special loads, right? Now, let's move towards questions directly now, right? First, let's cover questions from design philosophies and material specifications. So, let's keep on reading the questions and solve the questions as quickly as possible. And please be open to write down in the comment sections if there is any doubt, right? I'll respond it personally. According to IS 800 2007, design of steel structures, the limit state of strength does not include. So, limit state of strength is basically covering part of strength aspect of a particular structure, design of structure with respect to strength, right? Ability to resist loads, right? So, ability to resist factored loads. Now see, stability against overturning, corrosion and durability, a rupture of the structure, fracture due to fatigue, right? Obviously, in these three, A, B and A, C and D, they are talking about the strength part. In B aspect, they are talking about the serviceability, right? They are talking about the serviceability aspect of the structure, right? So, option according to IS design of does not include. So, option B is not included in design of strength, limit state of strength. But if you want to know what all are included in limit state of strength, you can see on the screen and click a screenshot of this, because this is very, very important. Limit state of strength, strength as governed by material, buckling strength, stability against overturning and sway, fatigue fracture and brittle fracture. All of these things are considered in limit state of strength. After that, limit state of serviceability, they consider deflection, vibration, fatigue cracks. Keep this in mind. This is fatigue cracks, fatigue fracture, but these are repairable damages, right? Whatever is the repairable damage with respect to fatigue is covered in limit state of serviceability, right? So you need to consider this aspect, because directly questions are asked. I'll show you. Corrosion and fire resistance. These are all in serviceability aspect. Let's see our next question, which is again based upon the, let's see this question first. Which of the following is considered as ultimate safety limit in limit state design of steel structures? Ultimate safety limit. Again, they are talking about strength and what all is included in strength. Vibration in a structure causing discomfort. This is serviceability. Corrosion and durability. Again, this is serviceability. Repairable damage due to fatigue, not deflection. Actually, this statement is wrong. And fracture due to fatigue. So, fracture due to fatigue, this is considered in strength aspect. You can see fracture due to fatigue. This is considered in strength aspect. Fatigue cracks, which are repairable, are considered in serviceability. So, over here, option D is correct. After that, see this question. According to IS 800-2007, identify the property which is considered as a mechanical property of structural steel important for design, right? Poisson's ratio, unit mass, maximum percent elongation of standard gauge length on a standard gauge length, and the coefficient of thermal expansion. So obviously option C is correct over here, because for us, how much elongation is produced, how much ductile is our steel, how much strain is produced is very, very important with respect to the design aspect. So maximum percentage elongation of standard gauge length, right? And also as per, this is something extra I am telling you, as per IS 2062, for standard structural steel, minimum percentage elongation, it is 5.65 under root A. It is calculated as 5.65 under root A. This is some additional information I am giving you, because in some exams this have been asked. 5.65 under root A, this is the minimum percentage elongation of standard structural steel, where A is the area of cross section of the specimen, right? And for standard structural steel, mainly standard structural steel is none other than mild steel only. In that particular case, 23% is the minimum percentage elongation, right? 23% is the minimum percentage elongation. Keep this in mind. This has been asked in various exams. After this, next question. A load value obtained by multiplying the characteristic load with the load factor is known as. So in this particular question, they have mentioned the word characteristic load. Which method they are talking about? They are talking about limit state method. They are talking about limit state method, right? So characteristic load when multiplied with a partial safety factor due to load, this is actually equal to design load. So option C over here, this is correct. Very simple. Directly, basic concepts, directly they are asking from IS codes also. Now next question, select the correct statement related to increasing the carbon content in steel from 0.2 to 0.9%. So you all know this, you must know this. If you don't know, increasing the carbon content increases the strength of the structural steel but reduces the ductility, right? It increases the strength but reduces the ductility aspect. Keep this in mind, right? So there are actually three kinds of steel which we consider with respect to how much amount of carbon is available. It can be classified into three. Number one is low carbon steel. The stress strain curve of that particular steel is kind of signified like this. This is the low carbon steel, right? And in this particular case, in low carbon steel, the amount of carbon is from 0.1% to 0.25%. After that, there is medium carbon steel. The strength is increasing, right? Ultimate strength is increasing. The curve is somewhat like this. And you can see the maximum elongation or the strain is reducing. So ductility is reducing, but the strength is increasing. Medium carbon steel, it is from 0.25 to 0.6, right? And after that, high carbon steel, in which again, strength is increasing, but ductility is reducing. You can see the failure point is much closer to the axis, right? In this particular case, carbon content is varying from 0.6 to 1.1%, right? Now, this percentage I have taken from N. Subramanian book. In SK Duggal, it is somewhat different. It is not a standard thing, but I am telling you with respect to your knowledge, for your knowledge only. After that, they are saying they are increasing the carbon content from 0.2 to 0.9%. That means they are making the carbon from or changing the standard steel from 0.2% carbon, which is a low carbon content, to 0.9, which is a high carbon content, right? So they are kind of converting the steel from low carbon steel to high carbon steel. Strength will increase, ductility will reduce, right? So increasing carbon content in steel increases the yield stress and reduces the ductility. So option D over here, increasing the carbon content in steel increases the yield stress and reduces the ductility, right? Obviously, the ultimate strength is also increasing, yield stress is also increasing, right? Next question. In structural steel work, it is mentioned that ISLB, what is ISLB? Indian Standard Low Beam, 500 at the rate 735.8 Newton per meter was used in work. It indicates that the section is, so ISLB is all the beam sections are I-shaped sections, and this represents the depth of the I section, right? So over here, depth of the section is 500, and this is the dead weight, 735.8 Newton per meter is the dead weight. Yes, so it is an I section which is 500 mm deep and self weight is 735.8 Newton per meter, right? After this, next question. Rolled steel angle sections are classified as, yes, there are total three types of angle sections: equal angle, unequal angle, and bulb angle sections. So A, B, and C all are correct. So option D is the correct answer. If you don't know what is a bulb angle section, it is somewhat like this, right? There is a mass which is coming outwards from the top of the angle section. This is to increase the stiffness of the section, right? Basically, mainly we use this in shipbuilding, right? Shipbuilding, we generally use it, and it is to increase the strength of the cross section over here. And this question was asked in 2017. Bulb angles are used as in shipbuilding. Option C is the correct answer. This is to increase the stiffness of the cross section. Next question. As per IS, rolled steel beam sections are classified into. So beam sections are again I sections. I sections, there are total 5 types of I sections or 5 series of I sections which are available. Number 1 is ISLB, Indian Standard Dry Beam, Indian Standard Light Beam, ISMB, Indian Standard Medium Beam, ISHB, Indian Standard Heavy Beam or High Beam, ISWB, Indian Standard Wide Flange Beam, and last one is ISJB, Indian Standard Junior Beam. So total 5 series of beam sections are there. So option D again is the correct answer, right? Next, the load factor applied to wind or seismic loads in the design of steel structures. Now, this is a question which is a very tricky question. Why? In this particular question, you'll think that, sir, they're asking load factor. Maybe they don't have mentioned any type of method. So there are total 3 types of methods: WSM, limit state method, and after WSM there was ultimate load method, right? So first of all, in working stress method or WSM, we do not apply any load factor. There is no factor of safety applied to the loads. There is factor of safety applied to load in ULM, which is known as load factor, and there is a factor which is applied to load in limit state method, which is known as partial safety factor for loads. Now, with respect to which method you need to mention, most of the students will answer 1.5, because in limit state method we consider 1.5. But in question they do not have mentioned partial safety factor. Word partial safety factor is not mentioned. Partial safety factor specifically is mentioned for limit state method, and load factor word or term is used for ultimate load method. You can see it in the IS code as well, IS 800 1984 as well. You can see this. Load factors are specifically mentioned, term load factor is mentioned for plastic design or ultimate load method. And when with the dead load and imposed load, load due to wind or seismic is considered, load factor is considered as 1.3. Why I am saying this? This can be relevant over here because this year engineering services exam prelims, same question, same concept or same total provision was asked. So from my point of view, option B should be the correct answer, right? But in most cases, they have answered 1.5. And I guess the official key was also 1.5, right? So what you can do is you can answer when nothing is mentioned, consider limit state method. After this, the permissible bending stress in steel is, let's see, permissible word, again they have not mentioned any question, any method. No method is mentioned. Permissible word they use for working stress method, permissible stresses, right? And permissible stresses with respect to working stress method, you can see this over here on the screen right now. Axial tensile stress, when axial tensile stress is considered, 0.6 times Fy. After that, factor of safety is 1.67. Axial compressive stress, again 0.6 times Fy. Factor of safety is 1.67. Bending tensile stress, it is 0.66 times Fy. Again, this is 1.5 partial safety factor. Bending compressive stress, this is 0.66 times Fy. And again, partial factor of safety is 1.5. Average shear stress, this is 0.4 times Fy. It is 2.5. And maximum shear stress, this is 0.45 times Fy. And the factor of safety is 2.22. So this is 2.22. For this case, this is 2.22, right? The statement which is hidden over here, right, because of the screen resolution, let me just tell you over here. Permissible bending stress in base plates. Permissible bending stress in base plates for all grades of steel, this is 185 MPa, right? Permissible bending stress, it is 185 MPa for all grades of trees for base plates. Permissible bending stress, right? When you will consider Fy equal to 250, this can also be written as 0.75 times Fy, because in most of the questions in various state level exams, they have regarded bending stress as 0.75 times Fy. So that bending stress is actually for base plates. And this was also asked again in SSC JEE in 2007 or 2008, I guess, right? In one of these 2 years, they have asked this, what is the permissible bending stress in base plates? It is actually 185 MPa as per IS 800, 1984. Keep this in mind. This is very, very important. Because recently also in Telangana Service Public Commission, they have asked a question like that only. So over here, they are asking us permissible bending stress in steel. Bending stress is 0.66 times Fy. So this is actually, you need to substitute Fy equal to 250 and you'll get the value, right? You can substitute and you can get the value over here. After this, next, all of these permissible stresses, keep this in mind, will be increased by 33.33%. Again, this is very, very important. All of these bending stresses are increased by 33.33% when wind load or earthquake loads are considered with dead and live load. So when the load combination is dead load plus live load plus minus wind load / earthquake load, whenever this combination is considered, in this particular case, all of these permissible stresses which you are seeing over here, they will be increased by 33.33%. These are the permissible stresses in members, right? This point is very, very important. Again, questions have been asked, not in SSC, but in various exams. After this, let's see next question. Let's see for connections now. In riveted connections, the allowance or increase that is provided to the nominal diameter of the rivet having diameter greater than 25 mm, so as to work out the gross diameter. So you need to find out how much increment you need to do for rivet hole, right? So D0 value, what is to be done? So in case when the diameter of a rivet is less than equal to 25, here it is 5 plus 1.5 mm, and when nominal diameter is greater than 25 mm, here it is 5 plus 2 mm, right? So this you need to consider whenever the diameter is greater than 25, so increment is 2 mm. So option C is correct. This has been asked multiple number of times, so many times it has been asked. The gross diameter of the rivet is the diameter of the rivet hole. This is very, very important because most of the students get confused in this. In case of bolts, we consider it as bolt hole only, right? In case of bolts, gross diameter is considered for plain shank portion. So in case of bolts, there is a threaded portion and there is a plain shank portion. So over here, this phi, this is nominal diameter also, and this is gross diameter also. But in case of rivets, and this is the nominal diameter of the rivet, and for rivet hole, when we'll consider, this is the gross diameter. So this is for rivet hole. Again, this is the confusion for most of the students. Keep this in mind. Option C is correct. After that, next, according to Unwin's formula, it is if T is the thickness of the plate in centimeter, the nominal diameter of the rivet is. So when thickness of the plate is in mm, then in that particular case 6.05 under root T. This is the Unwin's formula, 6.05 under root T. When I convert this thickness which is in mm into centimeter, then this formula becomes 1.91 under root T, right? So most of the students just remember this formula, but they forget that this thickness is in mm. When thickness is in centimeters, the formula will be converted like this, 1.91 into under root T. The maximum permissible stress for hand-driven in axial tension. For hand-driven rivets, they are asking. Again, this question is, I tell my students every time that just remember the table of permissible stresses for members also and for rivets also. They will not ask in GATE or engineering services, but they will ask in various state level exams and central level exams, right? So you can see for power driven, just remember this. For power driven, when we talk about shear, and after that when we talk about axial tension, and after that we talk about bearing, right? What is the permissible stress in these three cases for power driven rivets? For shear, this is 100 MPa. For axial tension, again 100 MPa. For bearing, this is 300 MPa, right? Now, for hand driven rivets, you just reduce these values by 20%, right? 80 MPa. This is also 80 MPa. And when you reduce this by 20%, now this will be 240. But in code, this is mentioned as 250 MPa, right? So hand-driven rivets have 20% less strength than power-driven rivets. So they are asking maximum permissible stress for hand-driven rivets in axial tension, right? So axial tension, hand-driven, 80 MPa. So option B is correct over here. But keep this in mind, all of these values which you are seeing in this table, these are for workshop rivets. These are for workshop rivets. And for field rivets, you need to reduce all of these values by 10%. For field rivets, all of these values are reduced by minus 10%. That means you need to multiply all of these values by 0.9. When nothing is mentioned in the question about workshop rivets or field rivets, right? Consider they have given values for workshop rivets only, right? Not for field rivets. Why I am saying this? Because again, this was asked once in engineering services. Very easy question, that's why. When the effect of wind or earthquake is taken into account, the permissible stress specified in rivets. What are the permissible stress in rivets? These are only. Now what do? They are increased by how much? They are increased by 25%. For members, permissible stresses are increased by 33.33%. 33.33%, this is for members, and 25%, this is for rivets. Keep this in mind. This is very, very important. Most students get confused. This increment, this is for which combination? Dead load plus live load plus minus wind load / earthquake load. It is for this combination. After that, let's move forward now. When two plates are connected end to end and are joined by two cover plates, the joint is known as, very easy. There are two cover plates end to end. It's a double cover butt joint. So what are the various types of joints? You can see again, right? When we talk about shear connections, there are total 3 types. One is lap connection, another one is butt connection. There are 2 types of butt connections. One is single cover butt joint and another one is double cover butt joint. And when we talk about tension connection, you can see a T section connected with a gusset plate and there is a tensile force, and in the connection there will be tension reaction in the bolts which will be produced. This is a tension and shear connection. When you resolve this particular applied load into its components, you can see this vertical component, it is producing shear in the bolts, and this particular force which is going outwards, this is producing tension. That is why this is known as tension shear connection, right? Shear connections are also known as bearing type connections. Mainly they are known as bearing type connections. So nothing is different. Because plates bear over the bolts, because slippage is allowed in this, right? So here answer is D, double cover butt joint. Next, An imaginary line along which rivets are placed is known as. So very easy. Either bolt line or rivet line. If you are using bolts, it is known as bolt line. We are using rivets, it is known as rivet line. Right? Screeve line and back line are some other names which we use. So option D is correct. So giving you a overview. So if this is your double cover butt joint, the top view of a double cover butt joint, what is a rivet line? If a dotted line or imaginary line passing through the rivets like this is known as a rivet line. Right? Now see, in this particular case, there are total, obviously in double cover butt joint, we always design one side and directly copy it on the other. So in this particular question, in this example, there are 3 rivet lines. So this particular diagram will be known as a triple riveted double cover butt joint. Right. So if there are 2 rivet lines, it will be known as a double riveted double cover butt joint. If there is a 1 rivet line, it will be known as a single riveted single cover butt joint, double cover butt joint. Right. Now see, a riveted joint may experience tearing failure of plates, bearing failure of plates, splitting failure of plates. Yes, all of 3. And there is another failure of plates, that is shear failure of plates. So total 4 failure of plates are there in reality, but here only 3 are mentioned. What are the failures? You can see bearing failure of plates, tension failure of plates, shear failure of plates, cleavage failure. This is also known as splitting failure of plates. Right? And 5th one, it is actually basically for tension members, block shear failure. So I'll ignore this over here. This is mainly for tension members. Right. So when we talk about connections in general, we do not consider that. So here in a riveted joint or a bolted joint, 4 types of failures we consider for plates. After that, for 4.6 type bolt conforming to IS 1367, respective to ultimate tensile strength and yield strength will be. So this is very easy. For grade 4.6, what do you mean by this 4.6? Just consider this 4. FUB, that is ultimate tensile strength of bolt, will be considered as 400 MPa. Right? And FYB, it will be, take out this 0.6 and multiply this by 400. So this will become 240. Right? So 400 and 240. So ultimate tensile strength is 400 and yield tensile strength is 240. Option A. Next. The minimum spacing for M20 bolts for grade 4.6 according to minimum spacing criteria, what it is? Minimum spacing criteria, it is for either pitch or gauge length, right? So this is 2.5 times nominal diameter of bolt. This is either a minimum pitch or minimum gauge, right? 2.5 times nominal diameter. So 2.5 multiplied by 20, that is 50. So option A is correct, right? So see, this was asked in 2020. So simple question, such simple questions are asked directly codal provisions. Again, I'm telling you. What is the maximum pitch for bolts allowed in lap joint? So maximum pitch criteria in compression, 12 times T or 200 mm, whichever is less, where T is the thickness of the thinner member. There are total 4 maximum pitch criterias. Again, you can click a screenshot if you want. This is important. A lot of times it is asked, right? In case of tension members, it is 16 times T or 200 mm maximum pitch. In case of compression members, it is 12 times T or 200 mm, right? After that, there is one more codal provision. maximum pitch over here, the distance between the centers of the two adjacent bolts should not exceed 32 times T or 300 mm, whichever less. This is the overall. This is for pitch and also gauge, right? Because they have not mentioned the word pitch over here. After this, the distance between the center of any two consecutive lines in a line adjacent and parallel to the edge. What is the edge line? What is the edge line? Edge line is this is the edge of the connection, right? And in the line which is close to the edge of the connection, in which, in this particular case, the pitch value should not exceed 100 mm plus 4 times T. 100 mm plus 4 times T or 200 mm. This also you need to take care, right? And there is one more codal provision with respect to this 4.5 times time. Now, this is a double cover butt joint. Imagine there is extension of this joint further ahead also. This is one side and this is other side of double cover butt joint. In between, this is your two plates which are coming in between. This is your butting face. This is your butting face, right? From the butting face, you need to move 1.5 times B, or the bolts which are coming in between, right? This 1.5 times B, maximum pitch cannot exceed 4.5 times the nominal diameter. You can see 4.5 times the nominal diameter of the bolt, right? This is specifically for compression members. This is for compression members. That's why over here 12 times T or 200 mm is also mentioned. So both of these criteria should be fulfilled. Generally, no one will tell you about this criteria, but it has not been asked, but in future they can ask, because now they are touching some concepts or codal provisions they have not asked before. Let's move ahead. The minimum edge distance and end distance for the center of any hole to the nearest edge of the plate or sheared or hand cut flame elements, right? What is the minimum edge distance? For hand and flame cut elements, it is 1.7 times the diameter of the bolt hole, and for machine cut elements, it is 1.5 times the diameter of the hole diameter, right? So spelling of the hole was mentioned wrong in the paper. Actually, this is hole, like this, right? So 1.5 times the hole diameter is for machine cut elements, and for hand cut elements, this is 1.5 times. So answer is B. Next question. The strength of the riveted lap joint is equal to its shearing strength, bearing strength, or tearing strength, right? So strength of the riveted joint, it is, so let's say this is regarded as PS, shearing strength, bearing strength is regarded as PB, tearing strength is regarded as PT. So minimum of PS, PB and PT is regarded as the strength of the riveted joint. So least of the three. Option D is correct. Calculate the number of M20 bolts required to connect the flange of ISSC, Indian Standard Special Channel, ISSC 200 column, and a beam ISMB 400, which is carrying a reaction of 140 kilonewton due to factoral loads. Take the strength of each bolt as 45.3, right, kilonewton. You need to find out, calculate the number of bolts. So number of bolts always equal to what? Factored load and divided by total factored load divided by the strength of the bolt. So strength of the bolt or rivet is regarded as bolt value or rivet value. So bolt value or rivet value is given as 45.3. It is bolts, so bolt value. So this will be 140 divided by 45.3. This is it will be closer to 3.1. So next big, this is option D. Number of bolts required should be equal to 4, right? Keep this in mind. 140 is given as factored load. If it is given as working load, you need to multiply 1.5 with that. Next, see, this is a good question which was asked in 2020 and which I generally teach in most of my batches also. You can see in a double riveted, double cover butt joint. So double riveted, double cover butt joint they are asking. So double riveted, double cover butt joint. So that means there are 2 bolt lines on each side and not bolt, rivet on each side, 2 rivet lines on each side, and each rivet will be subjected to double shear because it's a double cover butt joint. It's a double shear. There will be double shear. After that, they're talking about we need to calculate per pitch length. So per pitch length, only one pitch length or one gauge length you need to consider. So in one gauge length or one pitch length, number of rivets will be equal to number of rivet lines. So how many number of rivets are there? 2 rivets are there in this case. 2 rivets are there. I'm repeating the statement. In one gauge length or in one pitch length, number of rivets or bolts will be equal to number of rivet lines or bolt lines. Because there are 2 rivet lines, there will be 2 rivets, right? After that, you need to calculate the strength in shearing, PD, and the strength of one rivet in single shear, it is PS, right? So if I consider one rivet in single shear, right, in single shear, the strength is PS. In double shear, it will be equal to how much? If a rivet is subjected to double shear, it will be 2 times PS, right? It will be 2 times PS. Now, total number of rivets, it is equal to 2. So, 2 times PS multiplied by 2. This is equal to 4 times PS. Option A is the correct answer. Read this question again. Here they are saying double riveted, double cover butt joint. You need to calculate the strength of this shaded portion, right? You need to calculate the strength of the rivets in this shaded portion. All of these rivets, both of these rivets will be in double shear. That's why we have multiplied by 2. How many rivets are there? There are 2 rivets. So that's why again 2. It becomes 4 times PS. Option A is correct. Next question. So if P and D are pitch and gross diameter of the rivet, the efficiency of the riveted joint is given by. So efficiency is equal to strength of joint divided by strength of solid plate. Right, this strength of joint, this is equal to minimum of PS, PB and PT, right? That's why we are considering it. Efficiency, right? Now see, they are talking in terms of plate only. So strength of joint I'll consider in terms of plate, PT. PT I'll consider. Now what will be the strength of the plate with respect to PT? PT will be equal to, if there is one bolt, it will be equal to permissible stress and tension sigma 80 multiplied by the net area. B minus, or sorry, this B not, it will be P. It will be P because we are talking in terms of pitch. Pitch minus the diameter of the hole divided by, multiplied by T, thickness, sigma 80 multiplied by the solid plate strength, so P multiplied by T. So here sigma IT and sigma IT get cancelled out. T and T will get cancelled out. Answer over here it is P minus D by P. This is your efficiency, right? So answer over here is option C. Next question. Design of riveted joint is based on assumption. Which assumption? So actually there are four total 6 assumptions of riveted joints. These are the assumptions you can see. Again, please click a screenshot. A load is assumed to be uniformly distributed among all the rivets. This is your number 1 assumption. All the rivets will be taking load equally. This means if there are n bolts and P is the total load, one rivet or bolt will be taking P by n force or load. Shear stress is assumed to be uniform over the gross area. Gross area is the area of the rivet hole. Bending stress is neglected. Friction between the plates is neglected. Bearing stress also is considered as uniform. And after that, tensile stress distribution also is considered as uniform in between the rivets. These are the total 6 assumptions. See, A, B, C. Load is uniformly distributed among all the rivets, correct? Shear stress is uniformly distributed over the gross area, correct? Bearing stress is also uniform, correct? All options are correct. Option D is the correct answer. When plates are exposed to weather, tacking rivets are provided at a pitch of tacking rivets or tacking bolts, one and the same thing. Not same thing, but conceptually same thing. They are provided to make the members which are connected back to back to act as a single unit. They will not take any load. Their maximum spacing when they are not exposed to weather, it is 32 times T or 300 mm. And when they are exposed to weather, because they are asking over here, when they are exposed to weather, it is 16 times T or 200 mm. Option B is correct. Next, you need to pick up the correct statement with respect to tacking rivets or tacking bolts. Tacking rivets are used if the minimum distance between the center of the two adjacent rivets exceed 12 times T or 200 mm. Yes, in case of compression, it will be correct. This statement is correct. Tacking rivets are not considered to calculate the stress. Yes, tacking rivets do not take any load. Tacking rivets are provided throughout the length of the compression member composed of 2 components back to back. Yes, throughout the length you need to provide. So all of these 3 statements are correct. Option D, all options are correct, is correct. Next, IS 800 1971. This is older than 1984. See, older than 1984, it was asked in 2018. This is the drawback of SSC JEE. Recommended that in splice plate, the number of rivets carrying calculated shear stress through packing greater than 6 mm thick, it should be increased by 2.5% for every 2 mm thickness of plate. I am giving you the codal provision. This is for packing plate. When packing plate is provided, then you need to increase the number of rivets. You need to increase the number of rivets by how much? 2.5% for each 2 mm. For every 2 mm thickness. And one more thing, it is to be provided when thickness of packing plate is greater than 6 mm. This 2.5% increment has 2 mm increment has to be done for every 2.5% when thickness of packing plate is greater than 6 mm. Right? This is as per the old code, IS 800 1984. But as per 1984 also and IS 1971 also. But as per IS 800 2007, as per the new code, you need to actually reduce the strength of the shear strength of the bolt by how much? 1 minus 0.0125 into thickness of packaging plate. Right? So now in the new code, this codal provision has been changed. Again, extra information I am giving you, which is required. Next. In the case of lap joints, the minimum lap length not to be dash times the thickness of the thinner part or 40 mm. So it should not be less than 4 times T or 40 mm. Right? Keep this in mind. After this, next. Which of the following is fillet weld? Mitre, single J, single bevel or square? Actually, it is mitre. What is a fillet weld? Fillet weld, it is used to connect members which are on 2 different planes. There are actually 3 types of fillet welds. This is a convex fillet weld. This is a concave fillet weld. This is a concave fillet weld. And mitre, it is somewhat like this. You need to consider a isosceles triangle like this. This is mitre. This is the idealized version of a fillet weld. Right? So option A is correct. These are the butt welds which you can see on the screen. Various types of butt welds: single square, single bevel, single double square. After that, single V and double V, single J and double J, single U or W. Mostly, whatever it is single, whichever butt weld it is single, it considers partial penetration of the weld. It considers partial penetration of the weld. And whatever is double, they will consider full penetration of the weld. They will consider full penetration of the weld. Keep this in mind. This is very, very important. Next. The actual thickness of the butt weld. This is asked in this question. The actual thickness of the butt weld when compared with the thickness of the plate, it is actually can be less or can be more also. Right? In case of full penetration, it can be more. In case of partial penetration, it can be less. Right? Option B is correct. For a standard 45-degree fillet weld, the ratio of the size of the fillet to throat thickness. Ratio of the size of the fillet to the throat thickness. 45-degree weld is this only. 45-degree weld, in which angle between the fusion faces, it is 90 degrees. When angle between the fusion faces, let's say this is theta, this is equal to 90 degrees. This is a standard weld. Right? Now in this particular case, throat thickness, you need to consider perpendicular to this. So this is your throat thickness. Right? So throat thickness over here, it is equal to S by root 2 in this particular case. And they are asking size divided by throat thickness. So this is root 2 divided by 1. Right, so root 2 is to 1. Option C is correct. And C, this is your theta. And when you say 1 divided by root 2, you can just write down like this: throat thickness, it is equal to K times S. This K over here, this is dependent upon the angle between the fusion faces. And based upon this, there is a table 22 which is very, very important of IS 800, and you need to remember this table. A lot of state level exams, PSU exams, they have been asking this a lot. Angle between fusion faces, when it is between 60 to 90 degrees, the value of K is 0.7. From 91 to 100, 65. From 101 to 106.6. From 107 to 113.55. From 114 to 120.5. So you are reducing how much? You are reducing minus 0.05. minus 0.05, minus 0.05, and again minus 0.05. You are reducing 0.05 again and again. Next question. From this table only you can see the angle between the fusion faces cannot be less than, theta cannot be less than 60 degrees and theta cannot be greater than 120 degrees. From this table only you can see. Based upon this, next question is asked in 2017 SSC JEE. Fillet weld is not recommended if the angle between the fusion faces is less than 45 degrees, greater than 120, less than 60, greater than 145. So B and C over here are correct. Option C. Next question. The fillet weld whose axis is parallel to the direction of the applied load is known as. So when you consider a lap joint in case of a fillet weld, two plates being connected like this, simple case of a visualization. So the fillet weld provided on side, this is known as side fillet weld, and this is known as end fillet weld. This is known as end fillet weld, right? So on the sides, load applied like this, on the side, it is side fillet weld. Maximum size of the fillet weld for plate with square edges. So for plates with square edges, it is thickness of plate minus 1.5. You can see over here. For square edge, it is figure 17 of IS 800 of 2007, right? IS 800 2007. It is T minus 1.5 mm. You can see over here. 1.5 is subtracted from the top, right? And for rounded edges, it is 3 by 4 times the thickness of the rounded edge. So answer over here is option A. Next, the minimum length of the intermittent fillet weld shall be, minimum length of intermittent fillet weld is 4 times S or 40 mm. 4 times S, 4 times the size of the weld or 40 mm. Minimum length of an intermittent fillet weld. Next, the effective length of a fillet of length L is, length L over here, this is the actual length which we are providing on the site. Actual length which is provided on the site. The effective length is the length which is responsible for bearing the load. L minus 2 times S, this is equal to what? Effective length of weld, L minus 2S. Next question. So before moving to the next chapter or question, so you all know this, that SSC JEE mega mock test we are conducting on 26th of May, which is very, very important. You all should go for this examination. It will be conducted between 1 PM and 3 PM. And the examination will be online mode from your home only. Please do register for this examination. And there is very nominal fee, only 100 rupees. Very less it is, right? So please do register for this examination, which is being conducted by Ace Learning Academy and Ace Online. Let's move forward to members now. Tension, compression and beams. You can see as per IS 800 2007. As per IS 800 2007, what is the maximum value of effective slenderness ratio of a beam strut tension member for the following? Please answer this. Members carrying compressive loads resulting from dead loads and imposed loads. After this, member always under tension. Member subjected to compressive resulting from combination of wind or earthquake actions. These are the options. You need to find out maximum slenderness ratio. It is based on this table only. For all the for pure compressive members, it is 180. For tension members subjected to reversal of stress, this is again 180. And after that, a member subjected to, it is a compressive force, right? A member subjected to compression, but there is reversal of stress, then again 250. After this, compression flange, it is 300. Compression flange of beam, it is 300. And after this, a member normally acting as a tie, but there is reversal of stress due to wind or seismic loading, you need to consider 350. And for pure tension members, it is 400. Right, this table, it is table number 3 of IS 800 2007. Very, very important. Based upon this table only, they are asking. Member carrying compressive loads and resulting from dead and imposed loads. This is a 180 value. Members always under tension. This is 400. And members subjected to compressive resulting from combination of wind or earthquake. This is 250. Right. So 180, 400 and 250. 180, 400 and 250. Option B is correct. This is again from table number 3. After this, next question, which type of member in tension will not experience any shear lag? In tension members, we all know this. If any member has some unconnected portion at the connection, it will be subjected to shear lag, right? I section with the bottom flange connected to the gusset plate. So I section which is connected with a gusset plate like this. So over here, this is your unconnected portion. This will be subjected to shear lag. An angle section connected with one leg with the gusset plate. Like this. Again, this is what? It will be subjected to shear lag. There is some unconnected portion. Two angles back to back on both sides of the gusset plate. So on both sides of gusset plate, it will be like this. Again, this will be subjected to shear lag. As per new code, it will be subjected. But as per old code, it will not be subjected. A rectangular plate connected with gusset plate. Right, like this. This will, again, entire portion is connected. It will not be subjected to shear lag. Option D. Other than that, all three portions have some unconnected portion. They will be subjected to shear lag. Next, which of the following is not a mode of failure in tension members? Net section rupture, gross section yielding, local buckling, block shear failure. You all know this, that the design tension strength, it is a minimum of TDG, TDN and TDB, that is gross section yielding, net section rupture and block shear failure. Local buckling is a failure in case of beams and in case of compression members. Lug angles. So lug angles are provided to remove the shear lag. They are used to reduce the length of the connection. Yes. They are unequal angles. No. They can be equal angles and they can be unequal angles. Increases shear lag. No. They make shear lag equal to 0. So B and C are not correct. Option D is also incorrect. Option A is the correct answer. Are used to reduce the length of shear lag. Next question. A lug angle is used with single angle member, not used with double angle member, used with a channel member. Single angle, double angle, used with a channel member. All options are correct. So actually it can be used with all of them, right? All options are correct. But in the sense, double angle, you cannot provide lug angles. So let's say this is your main member of a angle section. Lug angle can be provided like this. Lug angle can be provided like this. Right, this is your lug angle. And it can be provided with a channel section also. Like this. Again, lug angle can be provided like this. Right, these are lug angles on side. So two lug angles in case of channel sections are provided. So all options are correct over here. And in case of double angle, you cannot provide. After this, this is not important, that one. When a tension member is made of 4 angles with a plate as web, and how much is the allowance for holes is made when a tension member is made of 4 angles with a plate as a web. So a tension member made of 4 angles with the plate as a web. So over here, one angle section like this, 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 and in between you have provided a plate like this. Now you need to what? Connect it. How many holes are provided? One hole on each leg and 2 holes in the web. One hole in each leg and 2 holes in the web you have provided. So option C. This is the pure case of visualization. That's it. Next, the following statement S1, S2, S1 to S4 pertain to compression member. Okay, the effective length does not depend on the boundary conditions of the member. No, effective length is dependent on boundary conditions. Effective length is equal to what? K times L. Over here, this K factor is dependent on boundary conditions. L is the unsupported length. The elastic critical stress in compression decreases with decrease in slenderness ratio. This statement is wrong. This statement is wrong. It actually increases. The ratio of the effective length to the radius of gyration of the member is termed as slenderness ratio, correct? The elastic critical stress in compression is independent of slenderness ratio. No, elastic critical stress is inversely proportional to square of slenderness ratio. This is from Euler's formula. Right. So this is inversely proportional, S4. So S2 and S4 are wrong statements. S2 and S4 are wrong statements. They're asking which of the above are incorrect. S2 and S4 are wrong statements. Next, what is the criteria to decide the clear distance between 2 channel sections of a built-up column? The moment of inertia and radius of gyration should be equal about both the axes. About the major principal axis, moment of inertia and radius of gyration should be equal to decide the spacing between 2 column sections. The spacing is decided based upon that. Right? This spacing which corresponding to which moment of inertia or slenderness ratio is equal. This is also known as economical spacing. Right. So option C is correct. The moment of inertia about major and minor axis is equal. What is the effective length of the compression member having actual length L when effectively held in position at both ends and restrained against rotation at the other? That means one end is fixed and another end is hinged. In this particular case, it is theoretically it is 0.7 times L, and as per the IS code it is 0.8 times L. Option D is correct over here. Right. This is the IS code provision, table number 11 you can refer for effective length. The lacing are subjected to resist a transverse shear. Right. Lacings are designed for, lacings and battens both are designed for 2.5% of the column load. They're designed for 2.5% of the column load. Again, based upon lacing system, a steel built-up column is subjected to axial force 1000 kilonewton. The lacing system has to be designated for resisting a transverse shear of how much? 2.5% of column load, that is over here 1000. This will be equal to 25 kilonewton. Right, option C is correct. Next, in double lacing, the thickness of the flat lacing is, so for double lacing system, it is 1/60th of length between the inner end rivets, right? So option C is correct. This was asked last year also, last engineering services exam prelims as well. Next, the maximum axial load which is just sufficient to keep a column in small deflected shape. It's very easy. Crippling load, buckling load, all the options are meaning the same. Option D is correct. Next question. A column splice is used to increase the length of the member, right? Length of the column. Column splices, in general, splices, either it is flange splice or web splice in plate girder, either it is tension splice or either it is column splice. All are required to increase the length of the member, right? Outstanding length of a compression member consisting of channel is measured as, again, very simple, based upon pure visualization only. Imagine a channel section you have connected with a gusset plate through the web. What will be the outstanding length? Outstanding length in general is the free length. So over here, this is B, or width of flange, right? So nominal width of the section will be considered as the outstanding length. Allowable working stress corresponding to slenderness ratio of double angles placed back to back and connected to one side of the plate is reduced by. So as per IS 800/1984, the axial compressive stress is reduced by 80%. And also for single angle connected with single rivet, again, it reduced value of 80% is considered. So 0.8 is multiplied with sigma AC. Next, a compression member consisting of angle section may be, it can be a continuous member, it can be a discontinuous strut or discontinuous single angle, double angle, both. Option D is correct. Again, very easy. Compression member consisting of angle sections. Next, they are talking about struts. Right, strut is what? Compression member in a truss. Next, the width of the lacing bars in mm is kept as. So minimum width of lacing bar, let's say if I'm connecting it with a single bolt or single rivet, from the center it is considered as 1.5 times nominal diameter of the bolt or rivet, and from here 1.5 times nominal diameter of the rivet or bolt. Here it is 3 times the nominal diameter, right? Next, so 3 times or thrice the nominal diameter. Option B. A compression member always tend to buckle in the direction of, right? A compression member always buckles corresponding to the weakest axis. And about the weakest axis, you will get least radius of gyration and maximum slenderness ratio, keeping the length constant, right? For constant length about both axes. For constant length about both axes, maximum slenderness ratio, least radius of gyration will give you the buckling axis. Option A is correct. Next, the buckling load in steel column is, the buckling load in a steel column is dash related to strength, related to length, directly proportional to slenderness ratio, inversely proportional to slenderness ratio. Yes, it is inversely proportional to slenderness ratio. It is inversely proportional. More the slenderness ratio, less stable it is, less load it can take. The effective length of a battened column is increased by 10%. The effective length of a battened column is increased by 10%. For laced column, it is increased by 5%. Right? Next, angle of inclination of the lacing bar with longitudinal axis of the column should preferably be between, right? So when you consider a lacing system, the angle of the lacing is calculated with respect to the vertical axis, and this angle should be between 40 and 70 degrees, right? So between 40 and 70, right, to prevent the buckling of the lacing. 40 and 70. Option C. Next, questions from beams, purlins and plate girders. This is the last aspect. As per IS 800 2007, cross-section in which the extreme fiber in compression can reach yield stress but cannot develop plastic moment capacity. That means it will be able to develop MY due to local buckling. This will be regarded as a semi-compact cross-section, right? But it is able to develop yield stress. So the stress diagram will be linear. Only the extreme fiber has reached Fy value. Therefore, it is regarded as a semi-compact. In case of compact and plastic, the stress diagram is like this. The entire cross-section has yielded and there is plastic moment capacity which is reached. And in case of plastic, there will be full rotation which will be possible. But in compact, there will not be full rotation because of local buckling, right? But in both compact as well as plastic moment capacity will develop. And entire cross-section is yielded. That means plastic hinge forms. And what is slender? So as per slender, slender is not provided as per IS code. We do not provide slender cross-sections as per IS code. Next. So see, sometimes these kind of questions are asked in which there is heavy calculation. So I'll tell you to ignore these type of questions, right? Because see, options are very, very close. Yes, you may see that you will be able to answer it because here you are required to calculate plastic section modulus for a plastic cross section. It is nothing but Fy divided by 1.1 multiplied by Zp. This is the plastic moment capacity or design moment capacity. From this you can find out the Zp value. Answer is D over here, I am telling you. But I'll tell you to ignore these type of questions. Here there is calculation which is involved and options are very, very close. Waste of time. Which of the following is true? A compact or a plastic section can be used as a compression member. A slender cross section shall not be used as a compression member. This statement is actually true. We do not provide slender cross sections. As per IS 800, slender cross sections are not provided. Other statements are false. Why? Because plastic, compact and semi-compact are cross sections which is possible only for flexure members, that is beams, not for compression members. This classification is only for beams, not for compression members. So all other statements are wrong. Maximum allowable vertical deflection under the live load for cantilever members supporting brittle cladding in industrial building is, so see, for this I'll take you to this table number 6 of IS 800. This table is good table, right? Now, in case of this industrial building, let me just zoom it. For simply supported span, I'm really sorry. For simply supported span, it is spanned by 240 and spanned by 300. For cantilever span, it is spanned by 120 and spanned by 150. For us, brittle cladding is given. Brittle cladding, it is spanned by 150. Option D is correct. So you need to memorize this. You need to memorize this table. Why? And what to memorize in this? For purlins and girders, you need to memorize. For simply supported span and cantilever span of industrial buildings. And for other buildings, again, vertical loading, floor span and cantilever. That's it. Not other than these values. Only 3 aspects you need to remember from this table. Next. The rolled steel beam sections are most commonly used as beams because these provide rolled steel beam sections. Yes, correct. I sections we generally use because they have large moment of inertia. Actually, they have more section modulus. Statement is wrong, a bit wrong, but section modulus you need to provide. Right? Large section modulus is there. Less cross section area and greater lateral stability as compared to other shape of cross section. So option C is correct. The gross section of the web or beam is defined as gross section of the web of beam. So it is for a rolled steel beam. For web portion, which is responsible for taking shear stress, we consider the entire depth multiplied with the thickness of web. So D multiplied by TW. So total depth multiplied with web thickness. Option A. Rolled steel beams are dash mainly used to resist bending stress, used as independent sections to resist compression. Yes, we can use them. Used as an independent section to resist tensile stress. Yes. Beam sections, that is I section, can also used as compression as well as tension members. So option D is correct. All are correct. The problem of lateral buckling can arise only in those beams which have less moment of inertia about minor axis. Right. So moment of inertia about bending axis larger than the other. Yes, option A is correct. Moment of inertia about the bending axis more than the minor axis. Option A is correct. Web crippling is in beams generally occurs at the points where there are concentrated loading. So web crippling actually happens directly under the loads. When you apply a concentrated load, the web will cripple like this. It can be at the supports also. If it is at the support reaction will be from the bottom and crippling will be at the bottom like this. So web is trying to fold over the flange, right? In this particular case, under the concentrated load this happens. Option A. Yes, see this for plate girders. See this for plate girders. Good question it is. It was asked in 2021. It's a match the following question for intermediate transverse stiffeners, load carrying stiffeners, bearing stiffeners and diagonal stiffeners. Right? B, C, D, E. Right? So option A they didn't have mentioned. B, C, D, E like that they had mentioned. So intermediate transverse stiffener, load carrying stiffener, bearing stiffener, diagonal stiffener. And corresponding to these statements were given. What is the function of these stiffeners? So actually, clause number 8.7.1 of IS 800-2007 actually give the function of all the stiffeners. Right? So for intermediate stiffeners, it is to improve the buckling strength of slender web due to shear. For load carrying stiffener, it is directly under the concentrated load to prevent local crushing of web under the concentrated load. After this, bearing stiffener, it is load carrying stiffener was to prevent local buckling of web due to concentrated loading, and this is local crushing of web due to concentrated loading. This is bearing stiffener. After this, diagonal stiffener, it is to provide local reinforcement to a web under shear and bearing. So same statements they had mentioned in all of these four. So directly they are copying the codal provisions. This was asked for the first time. That's why I'm telling you new codal provisions they are asking. Again, this one. If D is the depth of the web and TW is the thickness of the plate girder, such that d by tw is less than equal to 400 epsilon. In this particular case, all the kind of stiffeners are provided, transverse stiffeners and both the longitudinal stiffeners, right? So option C over here is saying that you are providing intermediate stiffeners and longitudinal stiffener at 0.2 times d and the neutral axis, right? So in this particular case, all of the stiffeners are provided, right? So this is given in clause number 8.6 of IS 800 2007. You can refer this. I am giving you the reference because you need to study all of these codal provisions, right? If they can ask one question, they can ask other questions also, right? So this is the total codal provision 8.6. You can refer it. In a rolled steel beams, shear force is mostly resisted by web, right? Shear force is resisted by the web portion. This portion, shaded portion, we have seen this. Next, the flange splice in a plate girder is subjected to. So flange splice is for the flange plates. If let's say a flange plate is ending over here and below this the web plate is extending, bottom one also over here, you will provide a flange plate above and below like this, right? So flange splices are provided for the connectivity of the plate girder in the flange plates, right? They're designed for only bending moments. There is designed for only bending moment and axial force, right? If a web splice is provided, it will be designed for shear force and bending moment both. A web splice is designed for both bending moment and shear force. Next question. An angle section can be used as a purlin when the slope of a roof truss is less than 30 degrees. Again, this is important because in various exams also this has been asked. When the angle of the slope of the roof truss, this theta, it is less than 30 degrees, then you can provide angle sections as a purlin, right? Now this is as per the older version of code, IS 800 1984. In the new version of code, angle sections are not considered. Only I sections and channel sections are considered as purlins. Extra information again I am giving you. As per the new code, that is IS 800 2007, channel sections and I sections are considered as purlin sections. But as per old code, angle sections can also be considered, right? A sag tie in a truss mainly used to resist tension. See, in the word only tie is mentioned. So tie basically means tension only. But what is the functionality of tie? See over here. So purlin you are providing, let's say I sections you are providing like this. So to prevent the sagging of the purlins, you will connect the purlins, two different purlins with each other with a rod. This is known as a sag rod, right? This is to prevent sagging of the purlins. Because they are sagging, they are kind of pulling them back. Because they are pulling them back, there will be tension in them. So they are designed as a tension member. Select the incorrect statement from the following. Purlin is subjected to biaxial bending. Yes, this is correct. They are subjected to biaxial bending only because if there is a purlin like this, let's say this is an I section, channel section, angle section. Here they are subjected to gravity loading, that is downward like this, and wind loading like this. It will be 90 degrees, right? They will be perpendicular to the horizontal axis. So wind loading is always considered as perpendicular and gravity loading, that is live loading, dead loading, is vertically downwards like this. There is an angle. So when you will resolve this, let's say this is P. So P cos theta, it will be acting like this. And over here, this will be P sin theta. Right? So because of these two components, there is biaxial bending. The span of the purlin is center to center of the truss, correct. Purlin runs perpendicular to the truss, correct. Purlin is designed as a beam, right? Flexure member, not tension member. Option D is wrong. Right? Option D is correct answer over here. Next, the beam outside the wall, outside of the wall, the floor level above it is known as outside wall, spandrel beam. Right? Exterior wall load is transferred to spandrel beam. Right? So this was the last question of our today's session. I hope I was able to give you an overview of what kind of questions are asked in SSC JEE. Moreover, I have tried to cover 90 to 95% of the questions, right? I guess more than 100 questions we have covered in this one session only, right? So I hope I was able to give you an overview regarding how questions are asked in steel structures. Based upon this, you can do your further practice, right? Any queries you have regarding this particular subject, you can just comment down in the comment section. I'll respond it personally. And even if it is possible, I'll respond with you my contact number also. You can ask me the doubts corresponding to this particular subject for SSC JEE exam or any other state level examination. Please be open to ask doubts, right? And a gentle reminder once again that SSC JEE 2024 examination, a mega mock test again we are conducting on 26th May. Please do register for this examination as fee is very, very less and you'll get a good exposure out of this examination. So thank you for watching and all the best for your SSC JEE examination.